set of data, how are we going to analyze using this statistical software called SPSS? SPSS stands for Statistical Package for Social Science. Statistical Package for Social Science. That is what SPSS stands for. Statistical Package for Social Science. Now it is already up to version 32, the latest one. But never mind, you can get any version. The changes are very minor. In fact, the version I have is version 20. So that is it. What we are interested is we want to learn how to use it. Okay, we got it set up. Yeah. Okay. Let us start by introducing ourselves, because this is the first time we meet. Can you start from the back?
Hi, morning. My name is Tan Hong Siwai. I'm from KL. Currently, I'm with the BYD University Advisor.
What company?
Because it's the EV that when we did our case study, we talked about that these guys have all taken Tesla instead.
Oh, okay.
So if you want to buy an electric vehicle, you know where to go.
Oh,
You convert from your ICE to EV.
thanks.
Okay, Prashant, your turn.
Hi, good morning everyone. My name is Vishal. I'm from the maritime field, looking the ship. Who are you from?
Maritime.
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 Maritime. Yes.
What is the name of the company?
I'm freelance, so I was under sponsored by MIC.
MIC.
Yeah.
Oh,
Yeah,
oh,
so seem to be progressive training master now, training captain.
okay. Oh, this is appointed. And you are, of course, I know you.
This is Bala, retired.
Our chartered banker.
Yeah.
He has been expatriate overseas for so long in his life as a chartered banker. He's the Standard Chartered Bank. So and he's very strong in finance.
Number one in Malaysia.
That's what's the requirement.
Okay. Yes.
Licensing board member delegate.
What?
Licensing board member.
Licensing board member of delegate. What is this board?
We approve license to all the business in Colorado.
Oh, business license. Okay. So you have to do business in Colorado. Is the right way. And
Hello, good morning. My name is Asno Rizal Zakaria. You can call me Asno Rizal. I'm from Ijuk Selangor. And then my background, I'm one of the consultants for training purposes.
consultants.
Consultants for occupational safety and health.
Occupational safety and health.
Yes, and
You are consulting in occupational safety and health.
I know. Yeah.
You are news.
No, I'm not working at Ineos, but I'm trying to certify by
Okay. So now we have the right hand for Hosh.
Yeah.
Can you teach Hosh?
Yeah. Right now I'm one of the part-time lecturer in Conflict College.
You have a degree in Hosh?
No. My
material science. Oh, you're still an engineer. I think I know you are from China.
Yeah.
It's okay, it's okay. I already know you. Yeah. Okay. So,
This one, you want to move the slides, isn't it? Or you want to just pointer? Pointer ladies. You want to move
I
the
just
slides?
want to say that most I use there. Maybe just place.
The below my without finger.
Okay. So, what do you understand by normal distribution, descriptive statistics, inflation statistics? These three terms are very important in statistics. As I said, if you understand statistics, because you have done statistics before in your undergraduate or whatsoever, then you understand this course SPSS pattern. So I'm trying to ask you, what is normal distribution? What is descriptive statistics? What is inflation statistics? Just these three terms first before we begin.
I mean, I think all of us know the normal distribution curve. It's the perfect bell curve.
Bell curve,
Where the median, mean, and
yeah.
molar safety. But descriptive, no, I can ask my question.
Okay. Is that yeah? What he said is true. When we say normal distribution, it means the data that we got is distributed like a bell shape. Most of the data is in the middle of the bell, middle of the curve. Some little data is at the extreme ends of the bell shape, but most of the data is in the middle of the bell shape. Then it depends also on how much standard deviation we are considering. Okay, it can be a high bell shape curve, it can be a low bell shape curve. So whatever it is, when there is an acceptable range of heightness in the bell shape, and then is considered normal distribution. Okay, that is about normal distribution. Why is normal distribution important in statistics? Why must the distribution of the data be normal? That means if you are asking for responses from a scale of 1 to 5, most of the response will be 3 in the middle of the curve, at the middle of the bell shape. 3. Most of the responses will be 3. Then you have some responses 2 and 4, but most is 3. Very little responses on responded with 1 or 5. Very little. So then you get a bell shape. Why is this bell-shaped curve, normal distribution, so important in research? Can't it be the data just any data, any shape curve, any type of distribution? Why must it be normal distribution? Why must the data that you collect be normal distribution? Are there instances where it is not in the shape of a bell, it is in some other shape? Is it possible? Possible. But then your assumption will be different. When you assume normal distribution, that means you are assuming that the sample you collected is a random sample representing the whole population. Then it is a normal distribution. If you assume bell-shaped curve, that i.e. normal distribution, then you are assuming that the sample you collected represent the whole population, and it is a random sample. You collected a sample randomly from the population. Random. Random means every unit in the population has an equal chance of being selected. We call that random. Equal chance. If the population is 1 million and your sample size you require is only 500, to be in the 500, all the 1 million people have equal chance to be in that 500. We call it random. If that is the way you do your sampling, that means whatever study you do on your sample of 500 will also be whatever analysis you do and you conclude on the 500 will be also the conclusion for the 1 million population. If you conclude that the mean from the sample mean you conclude is a certain number, that mean is the same as the mean of the population also. The mean, mode, median, standard deviation will be the same between the sample and the population because you took a random sample, a sample that represents the population. Then in this case, we say we need to show that the sample we collected is a bell shape. We need to show that first.
From the population, is that some kind of ratio
Huh?
for the random purpose? Is that kind of the ratio we need? Example, process if we get the data from the 5,000 data, represent maybe for the 1 million population example. So is it the ratio between the data we get and then the numbers of population?
Good question. The sample size is determined from tables, statistical tables, because statisticians have noted that the sample size does not increase proportionately with increase in population. No. You can have a sample size of 300 for a population of 5,000, let's say. If the population increase to 1 million, the sample size will probably increase to 330 or 340, a little bit only. And when it comes to a certain population, let's say more than 10 million or this, there's a maximum already. Maybe 400 or 420, 500, no more than that. Even if you have a population, the whole world population also, it may be 500, the minimum sample size. This is what statisticians have done study. They say the size of the sample does not increase proportionately with the increase in the population.
So the standard size is 384.
Huh?
384, the sample size.
Minimum. Yeah, for any study, there is a minimum sample size. Minimum. It is about, like you said, 3 or 4. If you go below that, you cannot use a sample with less than that amount, or that 3 4, you cannot use. There's a minimum. But what I'm saying is, if you increase the population also, there's only a slight increase in the sample size.
So the delta is the delta, the increase is not
proportionate. Not proportionate. When the population increase a lot, the sample size, minimum sample size increase only a little bit. So you must understand, if your topic involves random sampling, then you must show that the data you collect is a normal distribution first. If suppose you can't show that it is a normal distribution, not the data is not in the shape of a bell, then you have violated the normality assumption. You cannot use that data for your study. So it means that the first step you must do is to prove that if the data you collected is in the shape of a bell-shaped distribution.
And that's what you mean when you say normality.
Normality. Okay, understand that point. It can, but in another research study, in another topic, research topic, you already predicted that if you are not going to use random sampling, but rather you are going to select the sample. Selective sampling. In selective sampling, which is not random, that means you select respondents who can help you to answer your research questions. Selective. If that is the case, you don't need to prove normal distribution. You don't need. And the test is different. But if it is selective sampling, the results cannot be generalized. The results of your study cannot be generalized. Because it is only meant for that selection only. The result is only applicable to that selection. So in selective sampling, you don't need to prove normal distribution. But you can still test. You can still test. You can still use SPSS. But a different set of tests in SPSS we'll see later, which is for when the normal distribution is violated. There's another set of tests in SPSS. Okay. So it means that in any research study, the first thing we're talking about quantitative, we're not talking about qualitative study. Qualitative study has a different approach entirely. Okay. This SPSS is for quantitative study. That means the data is numerical. Quantitative study means the data is numerical. Qualitative study means the data is non-numerical. Non-numerical can be text data, audio, visual, all non-numerical data, which you cannot analyze using SPSS. SPSS can only analyze numerical data. If you are supposed to have qualitative data, so you have to convert it to numerical data first.
But why they call SPSS from?
Statistical package for social
For
science.
social science, but we can use for the qualitative.
You cannot use it for qualitative, because qualitative you have to use a different software called NVivo, which is analyzing text, analyzing words and sentences, analyzing themes, text. You see, there is a different software, not SPSS. So in SPSS we are only analyzing statistics lah. That means numerical values. All numbers.
Number crunching.
For quantitative. Okay? So quantitative study deals with numerical data. Okay. Then in a quantitative study, which is dealing with numerical data, the statistics you use can be either descriptive statistics or inferential statistics. Now, what is the difference between descriptive statistics and inferential statistics? The difference. Descriptive statistics describe.
Sounds like
Summarize.
Describe the sample. It describes the sample.
qualitative words. Good, bad, average. Is that something like that?
Something
Describing.
like that. So,
You're describing, not ascribing a number.
yeah, but still you need to convert, give it values.
Values.
When you want to analyze with the SPSS, you still have to give values. 1 is for this, 2 is for this.
Means we summarize and describe, right? Is it the data set idea from the
Descriptive means you are trying to describe the characteristics of the sample. That's descriptive. How many percent male? How many percent male and female? How many percent? You're trying to describe. How many percent in the various age groups? Age group 20 to 30, 30 to 40, 40 to 50, 60 above. In the various age groups, how many percent? Total must be 100% lah. So you are trying to describe the characteristics of your sample. You use descriptive statistics. And also to find the mean, mode, median is also descriptive statistics. What is the mean for the responses, mean responses for this construct? Most of, let's say you get on a Likert scale of 5, let's say you get the mean for this construct is, the mean response is 3.1. So that is descriptive. Mean, mode, median, standard deviation, and then composition of your demographic composition. We call it demographic lah. Gender, level, all these are demographics of the respondent. So you want to know how many percent of your respondent have degree and how many don't have degree. These are descriptive statistics and they are for demography. To describe the demographic of the respondent. Okay. They want to put the password for your room.
Yeah.
So each of your own ID number. So you just click on create a piece of paper. Your go accordingly. That's all.
Yes. Send me this.
Can we go like how I did this time, so we don't disrupt the
Now, what about inferential statistics? Inferential statistics, they focus on the variables in your study. We call them constructs. Constructs can be independent variable, dependent variable, moderating variable, mediating variable, control variable, all are called constructs. The general name for variables is constructs. So, inferential statistics focus on the relationship within your constructs. You are trying to infer something about the relationship. Inferring.
Inference.
That is inferential statistics. So you use correlation tests. Use correlation tests and you compare the relationship between groups. There are two types of hypotheses. One is hypothesis testing for correlation between variables. That is the first type of hypothesis. The second type of hypothesis is comparing relationship between groups. You are comparing groups. These are the two types of hypotheses. All are inferential. What can you infer? We call it inferential. It is not descriptive. It is not talking about mean, mode, median. It is talking about what is the relationship between constructs, variables.
We try to predict what?
Yeah. You are inferring because why you are inferring? Because whatever result you get, whatever statistical result you get from your study, it can be an inference for the population. You are inferring from your statistical study of your sample. You are making inference to the bigger population. Let me be clear. There is a difference between population, sampling frame, and sample. These three terminology you will come across in research methodology. When you talk about population, it is a population that suits your topic.
not that time.
But the sampling, okay, you talk about internet user, in Malaysia, internet user in Malaysia, the population is all the 14 states lah. But if you are conducting your study only in Klang Valley, it's enough, right? To study internet user in Klang Valley is enough, right? We call that user of internet banking in Klang Valley as your sampling frame. Maybe you have 3 million users in Klang Valley using internet banking. That's enough. You don't have to go around the whole of Malaysia to Sabah, Sarawak, right? Just Klang Valley now. Sampling frame.
The Klang Valley for the whole nation?
The whole nation, 14 states, is your population.
Yeah.
The whole 14 states of internet banking user is your population. But you don't need to go to Sabah, Sarawak, you don't need to go to the 14 states. You just need to concentrate on Klang Valley, which has about 3 million internet banking users. That's enough. Right? So it is called sampling frame. Clang value, your sampling frame. Then from that sampling frame, you extract a sample. The sample can be 400. Using statistical table, you find out what is the minimum sample size. Let's say the statistical table say minimum sample size 400. Just take 400 internet banking user from the whole clang value, from the whole sampling frame. Not from the population. Population means includes Sabah, Sarawak. So you understand these terms: population, sampling frame, and sample. Okay. So now we are clear what is descriptive statistics and inferential statistics. So what we want to cover here in this part 1 is assessing validity and reliability, dealing with missing data, ascertaining normal distribution, and conducting parametric tests. So the first one, validity and reliability testing. What is reliability testing? The reliability testing we are going to do in SPSS is to test the reliability of your, we are going to use questionnaire, your questionnaire scale. How are the responses consistent or not? You see, you must understand that for every construct. What are construct?
Constructs your variables.
Independent, variables. Yeah, variable. Variables. That means can be independent variable, dependent variable, moderating variable, mediating variable, control variable. As long as the variable is called construct. You must understand that in a questionnaire, your questionnaire must contain all the constructs.
Thank you.
Besides the demographic variable, besides the first section of your questionnaire is demographics. Demographic and respondent demographics. What is the gender, what is the occupation, what is the income. Then when you continue to the next section onwards in your questionnaire, is all constructs. So if you have suppose 6 constructs, then you must have 6 sections in your questionnaire. After the demography, there will be 6 sections in your questionnaire on the for 6 constructs. 6 constructs, 6 sections. So for every section, for every construct, we say you have a set of measures. In questionnaire, they are not called measures; they are called items. Some people confuse it; they call it questions. It's not question. In question, you must have question mark. There are no question marks in the questionnaire. In the construct section, there are no question marks. It is called items. Okay. So these items, which you got from literature, they measure your construct. They measure your construct. For example, the first construct is independent variable 1. So for independent variable 1, let's say you have 5 items. 5 items. But how do you know that the responses for these 5 items are consistent or not? How do you know? You can only know by doing a reliability testing. If suddenly you find that for independent variable 1, the first independent variable, for independent variable 1, you find that the answers for the items, for the 5 items, the answers for the items keep on changing. Sometimes the respondent answer put 3, sometimes put 4, sometimes put 1, sometimes put changing all the time. Then you know there is very little reliability, very low reliability. Your Cronbach alpha will be low for that construct. the minimum Cronbach alpha required for reliability is 0.7, 70%. If SPSS generate a Cronbach alpha less than 0.7 Cronbach alpha, the responses, your items are not reliable, your measures are not reliable. You have to revise again your measures because they are asking different things. They are not asking the same thing for that construct. They are asking, so once the respondent got a different understanding, they will answer differently. So you have 5 items for a construct, but those 5 items are answered differently, not consistent.
So,
Let's say Bala answered the independent variable one, got 5 items. Bala, you start answering the questionnaire, you are one of the respondent. Sometimes you answer 3, sometimes 2, sometimes 5, sometimes 4 on the 5 items. How can this happen? When it is measuring the same thing, it is measuring the same construct but different answers. Cannot, right? If suppose you decided the answer will be 4, it should be all 4, right? Correct or not? And you, another respondent, decided that the answer is 3, it should be all 3, right? Because it's measuring the same thing, right? So, that is what we call reliability testing, using Cronbach alpha.
So for that case, not consistent, can you give example?
You look at Cronbach alpha, and afterwards, when we do Cronbach alpha, for every construct, the Cronbach alpha for all the items in that construct is listed down. As like this. The last column, after you see, you calculate Cronbach alpha for every construct. That means all the items, all the data you collected for the items, you put into SPSS, and the SPSS will generate an output for that, and SPSS will generate the Cronbach alpha for that construct. A very detailed, in the last column, SPSS will tell you what if you delete this item, what will be your Cronbach alpha? We'll see it. If you delete this item, what will be your Cronbach alpha? If you delete this item, what will be your Cronbach alpha? So SPSS is telling you which item you should start deleting to increase the Cronbach alpha to more than 0.7.
if that is the case, then if each item has got a Cronbach alpha, then
No, not each item Cronbach alpha. Cronbach alpha is for the whole construct. Suppose you see that for the whole construct, the Cronbach alpha is less than 0.7. The Cronbach alpha for the construct is less than 0.7. Then of course you need to delete some item, right? The erroneous item. So how do you know which item you want to delete? SPSS will tell you in one column there. If you delete item 1, how much will you be your Cronbach alpha? If you delete item 2, how much will be your Cronbach alpha? If you delete item 3, how much Cronbach alpha? If you delete item 4, how much Cronbach alpha? If you delete the last item, item 5, how much will be Cronbach alpha? So that by looking at that last column of the output from SPSS, you know which item you have to delete. It guides you which item to delete.
And let's say that
This is only applicable if your construct, the Cronbach alpha for your construct is less than 0.7.
Yeah.
If your Cronbach alpha for your item is already more than 0.7, no need to delete. No need to delete
So what you're
again.
saying is, in a construct, you've got 10 questions, let's say.
Do good question.
10 items, 10 items.
When there are two questions, that's fine.
So it tells us, in that construct, if you remove any one of the 10 items, how it will impact the Cronbach alpha.
Yes.
What can you do?
SPSS will tell you, if you remove this item, how much will be your Cronbach alpha? If you remove the item, how much will be Cronbach alpha? If you remove this item, how much Cronbach alpha? So you have a guide which item you want to remove. This is provided the Cronbach alpha for your construct is less than 0.7. If it's already more than 0.7, don't need to delete any item. All the item can be used. Follow, right? Okay. So we say reliability is assessed by internal consistency, i.e. the degree to which the items that make up the scale are all measuring the same underlying attribute. It must measure the same attribute of the construct. And attribute is referring to the attribute of the construct. It must measure the same thing. If for item 1 you are the responder, item 1 you put 3, item 2 you put 2, item 3 you put 5, item then the next item you put 4, then 1. It's not measuring. It's not measuring the attribute. Follow, right? So to check whether the response for the items is consistent or not, we use Cronbach alpha. Okay. So if the Cronbach alpha for the construct is more than 0.7, that means the answers for the items are consistent. Follow, right? When there is a small number of items in the scale field, then Cronbach alpha value can be quite small. The number of items for the construct, if it is less, then it will affect the Cronbach alpha. So the best is you put in as many items as possible for every construct. Number one, if you achieve a Cronbach alpha less than 0.7 for the construct, you can start deleting the items that you want. That's the first purpose. The second purpose is you achieve higher accuracy for your Cronbach alpha. But whatever it is, research has shown that you don't have less than 3 items. Minimum is 3 items for every construct. Suppose you start deleting to increase your Cronbach alpha, you start deleting items. Don't delete items until you have 3 or less. Minimum you need 3 to find Cronbach alpha. 3 also is not a very good Cronbach alpha you generate. But still okay. Minimum 3 items must be left for that construct. Minimum. But this you do when you start deleting items, you make sure at least 3 is left for that construct. At least 3 items left. Okay. Okay, So another one is validity testing. Content validity refers to adequacy with which a measure or scale has sampled from the intended universe or domain of content. So you have 3 types of validity: content validity, criterion validity, which concern the relationship between scale scores and some specified measurable criteria. And lastly, construct validity involves testing a scale not against a single criterion, but in terms of theoretically derived hypothesis considering the nature of the underlying variable construct. The construct validity is explored by investigating its relationship with other constructs, both convergent validity and related similarity. So, validity testing is concerned with how valid is your construct. There can be situations when some of the independent variables have relationship with one another. When you are doing statistical testing, you are assuming that there is no relationship between the independent variables because the name is independent, right? That means no relationship between independent variables. The relationship is only between independent variable and dependent variable. That is your assumption in statistical testing. But then, when you run SPSS, you find that SPSS generate some results that show that some finite. It cannot be totally independent. Cannot. There must be some dependence between the independent variables. But up to a certain extent of multicollinearity, it is allowed, acceptable. Multicollinearity, that means the independent variables have relationship between each other, is allowed. Multicollinearity, we call it, is allowed up to a certain percentage. We will do testing called VIF, testing in SPSS. This is already outside of the scope. To test for multicollinearity, that means the relationship between variables, whether it is still within range or not. To test for multicollinearity, we use VIF test.
This is relationship.
Agent value and VIF.
This is relationship.
Multicollinearity.
But this is relationships among the
independent variables. Supposed to be independent, but still got some dependence. Up to a certain amount of multicollinearity is allowed. You cannot achieve 100% independence in most studies, but as long as within the range of multicollinearity allowed, I will test it using VIF and agent value.
What is the normal range that's acceptable?
For VIF, it must be less than 10. And then agent value must be more than 3. Like this, we will go that later for testing for multicollinearity. This you have to do to determine validity testing. For validity testing, you must do multicollinearity test using agent values and VIF. Later, so that is validity testing. The most important validity testing. Otherwise, your constructs are not valid. Then you have to find other constructs. All these constructs we are talking about, where do we get them? Where do you get all these constructs? From where? From the plug on the app? From? If you do survey, you are doing exploratory study. That is different. You have to interview people like that. So that is going on qualitative lines. Qualitative. But we are talking about quantitative. You have to do a quantitative study. From where do you get the construct?
From literature?
Literature, yes.
Good literature review.
That means a quantitative study cannot be conducted with insufficient literature. Cannot. Quantitative study is deductive approach. That means you are deducing. Deducing means you are confirming an existing theory, whether it works or not, to solve your problem. Whether an existing theory, management theory whether an existing management theory works or not to solve your problem. Deducing that. Okay, that's why you have to do hypothesis testing. When you do hypothesis testing, some of the hypotheses will be supported. If all the hypotheses are supported, then okay, you confirm that this theory can be used to solve your problem. But if some of the hypotheses are not supported, then you have to modify the theory. This is where your contribution comes. You are modifying or adapting the theory to solve your problem. So modifying or adapting means it can be as small as changing some assumptions. Every theory got assumptions, right? You say to solve this problem, you must change some assumptions in the theory. Okay, you're modifying the theory. But there must be a basic theory for your research study. And you're trying to prove that you're trying to confirm that this basic theory is solving your problem. That is quantitative research. Qualitative is different. Qualitative is develop a new theory, it has to be through interviews, through observations, through ethnography, through qualitative means, qualitative approach. It's different. That is developing a new theory.
Propose the new approach.
Yeah. People ask me, okay, how long does it take to develop a new theory, a new management theory? How long? I tell you, it will be more than 10 years. Then, how do people get PhD using qualitative research? If you are doing a PhD using qualitative approach, you are not developing a new theory.
Huh?
You are not developing an entirely new theory. It's not. You already have some guiding theory, but you are trying to just start in the middle there. You already have, you just want to provide answers, look for answers for your research questions. You already have some guiding theory, and you have some research questions on to solve the problem. So you want some answers for the research question. That is qualitative research. You still conduct case studies, interviews, all that, but to answer research questions. In theory development, new theory, new management theory, there is not even any research question. So you have to start very basic to develop a new theory. It will take you more than 10 years. Rather, you have to find out later what are the research questions that you want to develop your theory. That is later. But for people who do PhD in qualitative, they are just converting research questions to become interview questions. That's all. Research question 1 equal interview question 1. Research question 2 equal interview question 3. Research question 3 equal interview question 3. Research question 4 equal interview question 4. Just converting research questions into interview questions. That's all. But if you want to develop a new management theory which takes more than 10 years, you can't do that. Just converting, you cannot. You have to start even more basic, more fundamental, which will take you more than 10 years. If it is that way, you must reach a stage where you can even hypothesize. Even though, generally in qualitative study, if you do PhD in qualitative study, you cannot hypothesize. Generally, you cannot hypothesize because you don't know the variables. How you want to hypothesize? You are trying to find out what are the variables. You cannot hypothesize. But in a long period of research, qualitative research, where you are developing new theory, finally you will discover the variables. That time when you discover the variables, but that time when you discover the variables for your theory, that time you will hypothesize. That means after 10 years only you will be able to hypothesize. Then only you prove your theory.
But is it possible less than 10 years? No?
Cannot.
Cannot.
New theory cannot. But in quality research, you still you cannot hypothesize. You cannot. Quality research, initially you cannot hypothesize.
Yeah.
Initially you cannot. If you have only 3 years to do a PhD, you cannot hypothesize in quality research. Okay, let's keep that. That's not our discussion today. Okay, treating missing data. You have several ways. What is missing data? Missing data, what do you understand by missing data? They don't tick the questionnaire complete. Some part of the questionnaire is not answered. We call it missing data. If the missing data is serious, then you have to exclude cases pairwise. recommended. Exclude cases list-wise is not recommended. Only in one or two situations only you exclude cases list-wise. This thing, exclude cases list-wise, exclude cases pair-wise, SPSS will prompt you. You have to select. You have to tick either exclude cases list-wise or exclude cases pair-wise. There's an option button. When you click that option button in SPSS, it will ask you which one you want. Exclude cases list-wise or exclude cases pair-wise. Please click exclude cases pair-wise. Please remember this. Don't. List-wise is only in very limited circumstances. Okay? So that is the first rule. The second rule is if you choose to exclude cases, those cases must have missing values, a lot of missing values. If suppose in a questionnaire where you have 100 items, there's only one or two items missing, not answered, only one or two items not answered out of 100 items in the questionnaire. Should be okay. Don't exclude it. Don't click exclude. When you press the option button, it will ask you, do you want exclude cases this one or include cases this one? Don't. You just if the missing item is a lot, of course you got no choice. Just press exclude. Just click exclude cases pairwise. But suppose when you analyze the data, 100 items in this questionnaire, he forgot to answer only one or two. Don't exclude. You fill in the missing item with some value. Let's say 2 items are missing in a 100 item questionnaire. Only 2 items are missing. You fill in the missing item with some value. What is that value? You take the mean value for the variable. You take the main descriptive statistic will generate the mean. You take the mean value for the variable and put it in the missing item. It is only 1 or 2 lah. He forgot He forgot to answer 1 or 2 items. Who use the mean value for that variable? Put it into the missing item. Is allowed. Of course, it will impact your accuracy, no doubt, but the impact on the accuracy of the result is slight. But if it is serious, so many missing items, then you decide. Please exclude. And exclude cases pairwise, not listwise.
So the missing data will pop up in the SPSS.
No. SPSS will tell you what case numbers have missing values, and then you inspect those cases. You see, if you have 500 questionnaires sent out, you have so many questionnaires sent out. But if you receive response for 500 questionnaires, 500 respondents send back your questionnaire. It is using Google Form. You don't have to use manual. Use Google Form. All the items in your questionnaire, or everything in your questionnaire, you put it in Google Form, and then you put all the email address. Let's say 5,000 email address that you want to email. You press send. It will send to all the 5,000 people. That Google Form will be sent to all 5,000 people. And when they start responding, it will automatically be stored in the Google Drive. So you don't. So it saves you a lot of work, and you can generate descriptive testing. You want what pie chart? Just press pie chart. You want histogram? Press histogram. Everything come out. All the descriptive statistics come out. Descriptive statistics only will come out from the Google Drive. Inferential statistic correlation only will not come out. Then you have to use SPSS. So when you run SPSS, this data that is stored in the Google Drive, when you run SPSS will tell you the case numbers So now you have 500 cases, right? 500 respondents that you send back the response. You have 500 cases. SPSS will tell you what is the case number that has missing value. Then you check those case numbers. If the missing value is not serious, just put in the mean for that variable. Fill in the missing
When you
value.
say case numbers,
If the case number if you check a certain case number, let's say case number 35, that means respondent number 35, then you find that the missing value is serious, you delete it pairwise. Delete pairwise.
when you say pairwise means the entire.
The entire case will be deleted. So now you have 499 now. So you delete one, you have 499 left. So you see, when the answers start coming back, they start sending back the answers to you. The first person to send back your Google questionnaire will be case number 1. The second person to send back, to email back your questionnaire will be case number 2. So it will be case number 1, case number 2, up to case number 500. Let's say you receive 500 back. Hold on. And you start deleting one case, exclude cases pairwise, now it becomes 499. And then you start deleting another one, say case number 50, so it becomes 498. Like that. But don't let it fall below the minimum sample size. If minimum sample size from the table says it is 400, don't delete until it is less than 400. Then you cannot study it because it's less than the minimum sample size. Okay. So whether you want to delete or you don't want to delete depend on the seriousness of the missing value. Is the missing value a lot or not for that case? If for that case only 1 or 2 missing value, okay lah. Just put in the mean, just fill in the missing value. But if for that particular case, which SPSS will tell you what is the case number. If for that case number, the missing value is serious, 10 items not answered, you just delete it pairwise. Okay. This is what we call data cleaning. The first part of data cleaning is treating missing data. This is the first stage of data cleaning. You do data cleaning in SPSS. You want to use some advanced software, Smart PLS also. Smart PLS cannot do clean data cleaning for you. You still have to use SPSS first. Okay. And then, after you have cleaned the data, actually there is one more thing that SPSS can generate. SPSS can generate you erroneous data, which we call outliers. OUTLIERS, outlier data, or erroneous error data. That means data that is far from the rest. Data usually should be close to each other, but some data is far from the other people, like you, far from the rest people. So you are an outlier. Not all the people like you, but you are so far away. This type of we call outliers is shown in SPSS in the box plot diagram. There's another function in SPSS called box plot. You click on box plot, it will generate output of your outlier data. Case number what? Case number 39 is case number 39, case number 61. All the cases that are outliers will be generated under this function called box plot diagram. So that is also data cleaning. So data cleaning consists of consisting of treating missing data, and then what? Removing outliers. Let me see later. It is very easy. The SPSS tell you already what case number is outlier. So you just remove. But outlier must remove. No choice.
No, I'm trying to understand. Sometimes you will have outliers. interest rates, like black swan events. Those are outliers, isn't it? So how can you just say we remove outliers? Let me understand it. I try to understand because black swan events are outliers. True. They say. But if you remove them, that means you're not addressing issues of such black swan events. You know,
Your discussion is about black swan. Usually swan are white, but suddenly you find one case where the swan, the swan is black, so it's an outlier. It's an erroneous. It will affect your study lah. It will make your study invalid lah. So those are actually, you are correct. They are outliers. If you put the black swan case in your case study, or your whole case study will be wrong.
Distorted, huh?
Distorted. So he is giving a good example of outlier. The response for one questionnaire is for the response for one case. We have 500 cases now. The response for one case is so bad. If you put it in your study, in your analysis, everything will be distorted. So SPSS will tell you what case number are outliers. Please remove them. It is part of data cleaning.
It's a better we remove them we want to
Better
explain
we
only
remove.
the star.
Better.
Alright.
There are not many.
Yeah.
There are not many.
Okay, we can call it abnormal cases.
Abnormal. You can call it abnormal. Suppose the one guy will respond to their all four in his whole questionnaire. Definitely will be an outlier. How can all the whole questionnaire he is not interested in the questionnaire, he just put four. Okay, so we have done data cleaning in SPSS. This is treating missing data and removing outliers. Remove outlier, I don't need to put slide lah, you know. Because when you use the box plot function in SPSS, straight away give you the case number that are outliers which you have to remove. Okay. And then next step, once you have cleaned the data, the next step, now you have clean data, you know. Your data is clean now. You assess for normality. Assessing normality. You must show that the distribution of your data is in the shape of a bell curve. Bell curve or bell histogram lah to you. It must be in that shape. So you have to prove it. The proof comes from number one, skewness value. Skewness is an indication of the symmetry of distribution. That means the shape of the bell, is it leaning towards the left or is it leaning towards the right? If it is leaning towards the left, it is left skew. If it is leaning, the bell is leaning towards the right, it is right skew. Both left, if it is too much left skew or too much right skew, too much skew is not acceptable. There must be some skew. In fact, in some research topics, you cannot avoid a little skewness. You cannot avoid a little skewness in many research studies. But what is the acceptable range of skew? There is an acceptable range for skew. That means the bell shape is leaning towards the left or leaning towards right. Okay, acceptable range. Number two is the courtesies. It is about the thickness of the distribution. How tall or how tall or short is your bell shape? If your bell shape is too tall, so that it is not acceptable. If your bell shape is too low, too flat, it's also not acceptable. There's a range that is acceptable. So skewness and courtesies must be within some range. Many statisticians have produced the range. You take books on statistics, SPSS, they will give you the range. Of course, there are some differences in QQ plot line is a straight line. If all the data, this 500 data, is on the straight line or close to the straight line, so it looks like straight, then you achieve normality. You are not violating the normality. Your normality assumption is correct. QQ plot line is a straight line like this. So all the data is near to this straight line, on the straight line or near to the straight line, all the 500 data. Then you are not violating normality. That is another test, the third test. There's a fourth test, we did not include here. You can also generate a histogram. When you look at the histogram, does it look like a bell? Okay. This of course common sense. And there's another test called Ogomarov-Smirnov and Shapiro-Wilk. These two tests, KS and SW, is generated by SPSS automatically when you test for skewness and curtaceous. So skewness and curtaceous values are generated by the SPSS and also generated by another separate test called KS and SW. So 2 times skewness and curtaceous result were 2. The first skewness and curtaceous result is by the SPSS software. The second skewness curtaceous is generated by Ogomarov-Smirnov Shapiro-Wilk. So you have 2 results for skewness and curtaceous generated. For KS and SW, it will give you a significance value. A P value, significance value or P value. If the P value for KS or SW is less than 0.05, the P value shown, is less than 0.05, then the skewness or curtaceous is significant. That means you did not achieve normality. If skewness and curtaceous under KS and SW is less than 0.05, that means significant. That means the skewness and curtaceous is significant. That means it violated normality, violation of normality. We want a KS, SW, P values, 2 P values, 1 P value for KS, 1 P value for Shapiro-Wilk. 2 P values, these 2 P values, we want to be more than 0.05, that means not significant, that means your skewness and curtaceous is okay. Then you did not violate normality assumption. Understand or not? We want a P value for KS and SW of more than 0.05. That's what we want. Okay. So we want skewness curtaceous values generated by SPSS that is within range. This is the first thing, within range. And then secondly, we want KS and SW P values, 2 P values of more than 0.05. Then we can be 100% confirmed that we did not violate normality assumption. We achieved balancing distribution. Alright. Remember, we started this research with a normality assumption. We assume that the random sample will be normally distributed. This is our assumption. Looking at your research topic, you make this assumption. Because your research topic is like perception of internet users, perception of internet banking users in Klang Valley. This is your research topic. So the assumption is definitely, you are assuming that it is, because this random sample will generate a normal distribution eventually. This is you started research with this assumption. You are not doing selective sampling. You are not selecting internet users, no. But if you are studying like what do you call OKU, you know OKU? Orang-orang upaya. OKU internet banking user in perception of OKU internet banking user in Klang Valley, then 70 already. 70 cannot be a random sample. Follow. So you cannot use this bell-shaped, whatever, tuneless, courtesy, or no point. There are other tests for if there's no normality assumption, there's another set of tests. Okay. So you have to, when it so we have this one will come down. I don't know why. I can change the background. Same also. Just now, we assume that whatever statistic we got from our sample will represent the statistic of the population. Our sample of internet banking user in Klang Valley will represent all the internet banking user in Klang Valley. That means the sample represents the population. When we talk about sample, we talk about statistics. When we talk about population, we use the terminology parameters. But they are the same. If it is a normal distribution, the statistics of the sample equal the parameters of the population. That means the mean mode median of the sample equal the mean mode median of the population. If the mean is 3.1, for the sample, the population mean is the parameter is also 3.1. If the standard deviation is 2 for the sample, the standard deviation for the population, the parameter is also 2. Same. Because it represents what? The sample represents the population what? In a normal distribution. Then we use parametric tests. This whole here, parametric techniques. Parameter means population. Statistic means sample. Parameter means population. So we use a set of test techniques in SPSS called parametric techniques. Okay. But in SPSS also got non-parametric alternative. The parametric alternative, which means it is you did not achieve normal distribution. You are using selective sampling. That means it is not a bell shape, not a normal distribution. Then you must use non-parametric test, which is the parametric alternative. For this alternative you don't have, all these you don't have. But you have all these. For main Whitney U test, you use independent stability test. For Wilcoxon sign rank test, you use patch stability test. For Kruskal-Wallis test, you use one-way between group ANOVA. For Friedman test, you use one-way repeated measure ANOVA. These are the non-parametric tests for which correspond to this
with
Bayesian correlation is a parametric. I think this is better lah. This is better. Don't forget that slide. This is better. All these are parametric tests. Principal component analysis, factor analysis, cluster analysis, MANOVA, MANCOVA, linear distribution analysis. The use is for this. This is the use. These are all parametric tests. Parametric test means the statistic of the sample equal the parameters of the population. That means if the mean of the sample is 2.9, the mean of the population, which is the parameter, is also 2.9. Then we use parametric tests. All these tests we use. Okay. And then if we don't achieve normal distribution because we did selective sampling, so there's no way it can be a normal distribution, then we use non-parametric tests. And the non-parametric tests are Man-Whitney, this is the use. The non-parametric test is Man-Whitney-Wilcoxon test, and then Wilcoxon sign ranking test, and then Kruskal-Wallis and Friedman. These are the non-parametric tests. But I believe you will, in most of your studies, you will be doing parametric tests. And the non-parametric tests are not many in SPSS. If you are not doing if you are not using a random sample, then you use non-parametric tests. Because the statistic of your sample does not represent, because you are using selective sampling, so the statistic of your sample will not represent the parameter of the population. That means the mean of the sample will not equal the mean of the population, because you are using selective sampling. Selective, not random. Understand? So you use non-parametric tests. When you want to run SPSS, these are the tests available for non-parametric. So we have covered essential statistical concept. Any question?
can we have several questions for this assignment? This subject, what are questions will be asked in exam? So we to have some idea.
Okay, this is not a research methodology course. It's not also a statistical course. It is a training course to use SPSS. If we want assignment questions on this slide 1, then it is a separate, it is a research methodology course.
No, you said 30% marks from this.
No, the thing I will give after at 12 o'clock. I will give you a little exercise to do. Do the exercise and generate the output from SPSS. Then you get your 30%. Joey, this section is recorded. Okay, so we have finished slide 1. You want a break? Take a break. Yes, take some break. We can take a break for 15 minutes.
Are we getting the slides?
Yeah?
Are we getting the slides?
Yeah, I will send you the slides. I got your name there. I got your name. Don't worry.
Only for the person at time.
Yes, for the training. I will email you the slide, the recording. How many of these? this thing is not very
Let's say you want to sell a stay, but for the small one, or example,
You can order now. You order the thing. She got
So, is there is a thing, right?
so you just
The subjects, okay? Subject, and you get the data is from the staff.
because
You need to
yesterday
select.
Isla pick up the last one.
Okay, so,
The SPSS lessons. Today she said she got new ones already. So she asked, could you let your friends know? You can order. You already ordered it now.
because it's not represent
You just
information,
check
it's
the
just for the company.
shop. Ask them to do that.
it cannot be generalized to other companies.
Yeah.
Only for your non-participating.
No, no, no. So, example, the Oh, okay.
So if you don't use, cannot be generalized to other companies, then you have to use non-participating.
Full of equal.
That means you select
Because the sample is from our staff.
from your company.
This group, huh?
He escaped from the group.
You don't want to be.
He do alone. He is the one who do alone. This is the ground. And do alone. Actually, it's good.
My number is very simple. Hey, so you got ready, huh? Oh. Right, get the full sugar.
So for your assignment,
Let it read now. Because we're going to do training.
Yeah.
Oh, yeah.
our subject
You got
finance.
the internet only connection. You want sample those things. You waiting here now. If you do that exercise, you can really got more than you do that. I said you don't do that. Before, the girl said already got some license number. TC, CY, just wanted, you already got the license number. I said, you got yours? Just, she got it. I said, CY, just now we ordered this with me, the ID section. You got the license number. She already told me now.
The laptop, no, right?
No, you need to refer to Unipellet.
You need to refer to the book. You are
When you use SPSS, it is not steps.
Because
Unipellet will give you all the steps.
I already know it.
no, you already put inside the computer. If you want to read now, you can read now.
Oh, the books on.
I need to download from your handphone and put it in the computer.
Ah.
Save it in your computer.
Supposed to be like discotheque color. This one they use for discotheque.
Disco boy, what's your friend?
Huh?
What's your friend?
Hey, listen,
I think I need to charge my laptop.
did he get lost?
He lost it.
He shouldn't have.
Ayo, choker you. It's on all the way. Mine is on, but it's a sleep function.
Okay. You look at it.
You are speaking to your laptop.
Bro, where are you? We're waiting for you to start the class.
Because you keep handphone, after when you do this,
Okay.
refer very difficult.
Okay, he's coming, he's coming. I told him we're waiting for him to start the class. You got to open it up.
So when I'm showing the slide, you will be looking at Unipellet.
Okay. Okay. And you tell us page what and all that.
In now, this current one.
Yeah.
I like the title, SPSS Survival Manual.
You got it right. Yeah. The picture picture of them alive.
Survival manual. Ada orang pakai mah?
No, life boy.
Yeah.
Very hard to install.
Why?
A lot of steps.
Serious?
Install already.
Wi-Fi.
A lot of steps. This SPSS.
Okay, but install already.
Oh, if you want to help you, bro. Then, you need to open the computer, copy the link.
You need you write your eyes.
Boss, 25% tarik. Malaysia.
No, I thought the fee increased.
25%?
I thought the fee increased by now 1% or something. You know what?
25. That's only 1 hour ago.
I'm going to tell in the Middle East if you want to look at dollar or not.
Now, what is it called?
Now,
We want to
You have to
we
use
want to exchange
put it
the
in
old
your
currency. We want to
So when I
get
show
away
the slide,
with the
you
dollar.
have to look at
What's
this.
You go to S-class community lah. You don't talk.
Okay, let's start with part 2 of our SPSS. So in this part 2, we are going to look at how we name variables in SPSS. You cannot put the long name of the variable, it has to be abbreviated. And then what are the acceptable abbreviation for variable names? And then how you enter the data, how you clean the data. I talked about cleaning data just now, a lot of it, which is treatment of missing data and also removing outliers. And then checking scale reliability. I have talked about scale reliability just now, the Cronbach alpha, you remember?
Yeah.
And then how we choose the right statistic. Choosing right statistic means basically it is parametric or non-parametric statistics. Yes. So naming variables. You please open your palette, page 29. It's Beauty palette. You have Beauty palette in your laptop there. Page 29. There are rules for naming variables. That means the variables must have different name. Okay. Let's say you have a variable called behavioral intention. You put it as BI, capital B, capital I, BI, behavioral intention. Okay. Let's say this is your variable, behavioral intention, BI. And let's say you have 6 items under this variable, BI. So the first item you will put here as BI1, the second one BI2, BI3, BI4, BI5, BI6. That's it. That's how you name. Okay? So the first thing you see, after when I show you SPSS, SPSS has 2 views. One view is the variable view, another view is the data view. So when you open SPSS afterward, first thing you have to open is the variable view. I'll show you. So in the variable view, you have to define your variable names. So just now I said behavioral intention. You will define it as BI1, BI2, BI3, BI4, BI5, and BI6 because you have 6 items. Okay. And then each variable must begin with a letter, not a number. You cannot put there 1 BI, 2 BI, 3 BI, cannot. It must begin with a letter, not a number. Okay, that's the second rule. That means it must begin with A, B, C, D, E, F, etc. BI1, BI2. And then the third rule is you cannot put full stop, spaces, or symbols. All these exclamation mark, comma, question mark, asterisk, colon, like this. bi2 perfect. But you put b.i1, b.i2 cannot, because you have a full stop there. You cannot use full stop, you cannot use space, you cannot use symbols in your variable name. The fourth rule is you cannot include words such use as commands by SPSS, ALL, NEEQ. All these are command words in SPSS. If you type these command words in SPSS, you don't have to use the mouse. In SPSS, you can use to choose the mouse and click with whatever function you want, whatever command you want, you just click the mouse. Or you type in these letters, it also is also the second way to command SPSS. You cannot use command words. These words cannot use. If coincidentally you have used it, then you know why it is not functioning. Okay. And you cannot, your variable name cannot exceed 64 characters. That means all the numbers, letters and numbers cannot exceed 64. Which is very long lah. Usually we don't do that. We just make it very short. Okay. So that is about naming your variables. And then data entry using Excel. Okay. If you, when you receive your questionnaire responses in the Google Drive, I was mentioning this now, it is in Excel because there is no SPSS in Google Drive. Google Drive is all words and all Excel. So now you have to import the Excel file into your SPSS. There is an import function, import command with SPSS. Provided the Excel file is in your laptop lah, not in some other laptop. So your SPSS file, you're using the same laptop, you can import Excel file from downloading in the Google Drive. You download the Excel file of your data and import it into SPSS. So it must go line by line. I mean row by row lah. One row is one case. So if you have 500 cases, you have 500 rows. Rows and not columns. Rows. On top of it, the title, you have BI1, BI2, BI3, BI4, BI5, BI6, and then all the responses there recorded in one row for each case. Each case number is one row, not one column. So SPSS goes case by case, row by row, not column by column, row by row. One case is one row. Row is horizontal lah. Okay. So what happens if you are doing it manually? If you are doing it manually, you are not using Google Form. You are doing it manually. You send a manual questionnaire. I give you a questionnaire. Manually. Then you have to take all the data and put it into Excel file, right?
Yeah.
You have to create an Excel file, right? Manually create an Excel file, right?
Right.
Make sure it is row by row. So you have BI1, BI2, BI3, BI4, BI5, BI6 going horizontally, and then in Excel going horizontally, BI1 up to BI6 going horizontally in Excel, and then the next variable, let's say is what you call the next one, let's say is leadership, if it is leadership, then let's say you put LDR, leadership, LDR. So you put LDR1, LDR2, LDR3, LDR4, leadership style. Sorry, LS, leadership style. So LS1, LS2, LS3, LS4. Let's say you have 5 items, LS5. So BI1, BI2, BI3, BI4, BI5, BI6, and then LS1, LS2, LS3, LS4, LS5. If you have 5 items. And the leadership style, LS. So it is very horizontal. The responses are recorded horizontal. One line, or we say one row, is one case. So you have 500 lines, 500 rows, representing 500 cases in Excel. So if you have to do it manually, it's very cumbersome. You have to take the questionnaire and start filling in the Excel, row by row. Follow that. It's very cumbersome. That's why we could use Google for. Okay? And then click on File Save in the section marked Save as Type. Make sure Microsoft Excel Workbook is selected. You must select Microsoft Excel Workbook. This is if you are but when you download from Google Drive, you save it in Microsoft Excel Workbook. Use this. Don't use. There are so many you have to choose, right? But choose Microsoft Excel Workbook. Oh, okay, okay. Now you have your Excel file saved in this Microsoft Excel workbook. You refer page 55. And then you open IBM SPSS, your software. And you select File, Open, Data. From the menu at the top of the screen. File, Open, Data. Okay. And then in the section labeled Files or Type, you choose Excel. Excel file is either .xls or .xlsx. At the end there, find the file that you want, browsing lah. Click on it so that it appears in the file name section. Click on the open button, the screen will appear labeled Opening Excel Data Source. Make sure that there is a tick in the box, variable names from the first row of data. This one, and you tick this box, and then click OK. And then after that, once you have extracted the Excel file into your SPSS, now it's time to save. Now when you save, you click File, Save As. You must save as this one, .sav.
Typing manually or?
In your, no, it automatically appears. In Excel, we save as .xlx or .xlx. But in SPSS, we save it as .sav. Then click Save, and you name it up. Project 1.sav. Okay. Project 1.sab, for example. And then in the data editor variable view, you will now need to define each of the label values and message. Now you have to view. Now you click the variable view. So because you want to define every variable, you want to define the variable whether it is nominal, ordinal variable, ordinal variable, or scale variable. You have to define. But that has to be done in the variable view. Yeah. Just now we were in the data view. There are only two views in the SPSS. Data view or variable view. Data window or variable window. Only two windows in SPSS. Just now we were in the data window, the data view. Now, after we have saved the data in the data view, we have saved the data. Now we switch, we change to variable window, variable view. In variable view, we have to start defining the variable. They are nominal variable, or ordinal variable, or scale variable. We have to start defining. Okay. If you look at pilot page 75, these are the commands you have to click in SPSS to clean the data. There's a command, page 75. There's a command called analyze. So analyze, descriptive, statistic, explore. 4 times you have to click. 3 times, sorry. Analyze, descriptive, statistic, explore. 3 times you have to click. Three commands. And then click on the variable you are interested. For example, this is a variable, TP stress. Okay. Click on the arrow button to move them in the dependent list box. So all the variables that you want to clean, put it in dependent list box. This now part 1 we explain why we need to clean the data. We want to put in missing values, or if the missing value is serious, we want to remove the outlier. Now we are looking at the procedure. You can't remember all this without your book around. You can't remember these steps, right? You have your book with you, right? By your side, right? Okay. In the label cases by box, put ID variable. What is the case number? The ID is the case number. In the label cases by put the ID variable. In the display section, make sure that both is selected. Click on statistic button and click on descriptives and outliers. See, I told you, you need to click outliers, then it will tell you the case number that is outlier.
Yeah.
Then you remove the outliers. These outliers you will remove. The SPSS will print out for you case numbers that are outliers. Click on statistic button, 1 button, 2 button, 3 button, 4 button. 4 button you have to click to get the outliers. Can't remove all that. Click on the plus button under descriptive, click on histogram, click on stem and leaf to unselect. So 1, 2, 3, 4, 5, 6 button you have to click. This one is unselect. That means you don't want the stem and leaf diagram, you want the histogram. You select histogram, you unselect stem and leaf. Because stem and leaf is not so, you can't see very well the stem and leaf. Let us see histogram, whether the histogram show bell shape or not. Bell shape histogram. Okay. You know histogram, right?
Yeah, box.
And then lastly, click on options button, 1 button, 2 button, missing values, this dealing with missing values. Exclude cases. I told continue pairwise always. Continue, okay. So 1, 2, 3, 4, 5. So all the missing value cases of missing value will come out. Let's investigate one by one of the missing value. Is it serious or not? Okay. So we have dealt with, you see, not normality plot with test. When you click this one, not only histogram appear along, all the skewness, curtacies, QQ plot, when you click this, all will come out in the output. When you click OK, when you click continue and OK, the output come out. Like a printout. Come on. And it come out all the normality things. Come on. Skewness, skewness value, curtasis value, Fogomoros Spinot value, Shapiro-Wilk value, all come out. All the normality and the QQ plot line also come out. All. So this is cleaning data lah. So cleaning missing values, cleaning outliers, and also checking normality. Come under one group, data cleaning. Yeah, okay. Suppose you have removed outliers, you have treated the missing values, you have done treatment for missing value. Best thing you do not you run this again. Plots, descriptive, histogram, and then unselected, and then normative plots with that, and continue again. You do it to see whether after outliers removed, after missing values altered, is still the normality values, will it come out nicely or not? That means Fogomoros Spinot and Shapiro-Wilk, P values for these two more than 0.05, that means not significant. The skewness is not significant. And also the skewness and generated by SPSS is within range. And then whether all the dots, the data align on a QQ plot straight line. Check for all this again after you have removed outliers and you have treated missing values. Missing value we state enough, if it is serious, remove, exclude cases pairwise. Okay? And SPSS will do it for you. Exclude cases pairwise. It exclude the cases pairwise for you. Because it thinks that the thing is serious. Once you click this option, missing value, exclude cases pairwise, continue OK, and automatically it find for you the serious cases and exclude it. But I tell you, why not you run through your data, find those cases that are missing, those items that are missing, that are not serious. That means in one questionnaire, in one case only one or two items missing. Find those first and fill in the missing value first before you do this thing. Before you do this thing, exclude cases pairwise, do that first. Fill in the missing values that are not serious. Fill in first. Because if not, this function will exclude everything. Even the not serious ones will exclude. So you have to run through all your final cases. And those not serious, just fill in the missing value with the mean. Do that first. Then only you run this option, missing values, exclude cases pairwise, continue OK. Okay? And this function, even if find one missing value, so it will exclude. Because it doesn't know it's okay. And then scale reliability. We are testing for scale reliability using alpha. Alpha means product alpha. So these are the steps in Talent page 117. Analyze, scale move this in the box marked items. So if you have 4 construct, you need to do this 4 times. All the items for one construct, you move it into the box, into the window lah. There's a box, and especially got arrow there. You click the arrow, you highlight all the items for that construct, and you drag it. You don't drag, you click the arrow. All the items that you highlight will, once you click the arrow, all the items that you highlight will be transferred into the box in SPSS. You see this later. So, if you have 5 construct, you need to do this analyze, scale, reliability. You need to do this 5 times. You need to do all this. You need to do all this 1 to 6, 5 times. If you have 5 construct variable, you have 5 construct. Let's say you have 4 independent variable and 1 dependent variable. It means you have 5 construct. You need to do step 1 to step 6 5 times. Each time you do, you select all the items for that construct and move it into the box by clicking the arrow. You highlight and then click the arrow, it will move into the box. Okay? 5 construct need to do this 5 times. Step 1 to step 6, 5 times. Okay. In the model section, make sure you select alpha. Alpha is Cronbach alpha. Okay? Cronbach alpha must be more than 0.7 you see. In the scalable box, type in the name of the scale or subscale. Okay. Click on the statistic button in the descriptor section. Select item, scale, and scale with item deleted. In the inter-item section, click on correlation, and then summary. This is already looking for correlation. Correlation between the constructs. It will be like a matrix. It will look like a matrix. The printout will be like a matrix to show the correlation between the constructs. If the correlation is too low, less than 0.2, that means your constructs are not so good. This is the purpose of doing this. If the correlation is too low, you have to find other construct. You cannot use that.
What did you say the figure for correlation? What is below 0.2?
No, not 0.2. It is, it's 0.2.
Below.
If below that, if less than 0.2, you have to restudy that also. Click on continue and then OK. And so this is all change. Looking for scale reliability. If the column headed, that's one in the printout. Remember, just now you already click OK. Just now you already click OK. Continue OK. When you click this, the printout will come out. In the printout, you find in the printout there's a column. The title of the column is alpha, Cronbach alpha, if item deleted. This is the title of the column in the printout. It shows you values which are alpha values. The impact of removing that item from the scale, what is the impact on the alpha value? It will show. It will show you the new alpha value if you delete that item. So now you know that you have a guide which item you should start deleting. This only you do if the overall Cronbach alpha for the construct is less than 0.7. 0.7. if the overall chroma alpha is less than 0.7, then you need to look at this column. Alpha is item deleted. You need to look at this column in your printout. Because you here cannot simply delete item as you wish. You must know which item to delete. When you start deleting the lousy item, then your overall chroma alpha for that construct will increase. The idea is to increase the chroma alpha for that construct. Follow now? So we have to delete some item. That's why in a questionnaire, it is advisable that you put in as many items as possible. Because that will help you during the deletion process. If you have, but make sure finally you don't get less than 3 items. Minimum is 3 items. If your remaining item is 3 and still your chroma alpha is less than 0.7, forget about it. Cannot use. No reliability. Do you have Mr. Lee? Bala.
Mr. Lee.
Mr. Lee just now came and asked for Mr. Bala, his classmate, your working mate.
My working mate, I'm retired. In our DBA group, is it?
This from, you know, William, the technician. over
Yeah,
there?
yeah, yeah.
He said there's a person, Mr. Lee, just now came looking for Bala. He said, who is Mr. Lee?
You want it seriously, ah?
No, man.
Your famous
Maybe the immigration officer looking for you.
Everybody want to find you.
On the wanted list, bro.
Order to be.
Okay, let me ask him.
The second room, ah?
Oh, the call is from my friend, Datuk Nasi. Then I call him later. Oh, so who's Mr. Lee, my phone? I don't know who's Mr. Lee.
Mr. Lee, is it? Mr. Lee. Mr. Lim. L-I-M or L-I-M?
L-I-M, Lee.
Lim.
So you, if you have 5 construct, then you need to repeat that process 5 times to find the chroma alpha. 5 times you need to repeat those 6 steps to find chroma alpha. You need to repeat 5 times. If you find that any construct, for any construct, the chroma alpha is less than 0.7, then you need to do item deletion. You need to delete item. But if after deleting the item also, not less than 3 items, minimum 3 items left. If 3 items left, still chroma alpha is, for that construct, chroma alpha is still less than 0.7, no choice. That code cannot be used. That construct cannot use. Okay? I hope it does not appear to happen this way. I hope it still got 4, 5 or 6 items left and chroma alpha already more than 0.7 after you do deleting. I hope. Then chapter 10 on the statistical techniques that you have to, common statistical techniques in SPSS. Number 1 is correlation. Correlation means finding the relationship between constructs. We call it correlation. How significant is the relationship between constructs, between 2 constructs? We call correlation. If the correlation is significant, that means there is a strong relationship. This correlation is measured by a value called p-value. We come across p-value discount in Shapiro wheel. P-value means significance value. P-value for anything, for any purpose in SPSS, p-values that is less than 0.05 is significant. So, if the correlation of two variable, two construct, the correlation shows the p-value of less than 0.05, that means the correlation, i.e. the relationship, is significant. Once the correlation is significant, it was your hypothesis regarding the correlation, your hypothesis regarding the relationship is supported.
If less than 0.5,
If less than 0.05,
is supported.
supported. You are only interested to look at those correlation, those relationships that you have hypothesized. You don't look for relationships, correlation that you did not hypothesize. No. Once you have drawn your theoretical framework, your research framework, once you have drawn it with boxes and arrows, then you know what are the relationships between constructs that you need to hypothesize. So, let's say ID2 and DV, independent variable 2, ID2 and DV, you have hypothesized, for example. So you say your hypothesis will be there is a significant correlation between there is significant positive correlation, between IV2 and DV. That is one of your hypotheses. Then when you do your Pearson correlation test, it shows that IV2 and DV, the p-value of that correlation is less than 0.05, that means it supported the hypothesis. If the p-value is more than 0.05, that means not significant, relationship is not significant, that means that particular hypothesis is not supported. That means there is there is a relationship, but the relationship is not significant. Very weak relationship is it. Hold on, weak relationship, but not significant. Okay. And then in multiple regression, we have a set of independent variables and a dependent variable. So we call it multiple regression. Usually, you have bivariate and multivariate. Bivariate means one independent variable, one dependent variable. Bi. That means bi means two variables. One independent, one dependent. Bivariate. So in SPSS, you select bivariate. But if you have many independent variables and one dependent variable, we call it multivariate. In SPSS, you have to click multivariate. So you have bivariate and multivariate. The multivariate is the multiple regression. Also, you have a test for factor analysis. It allows you to condense a large set of variables or scale items down to a smaller, more manageable number of dimensions or factors. In factor analysis, there is a function as well as for factor analysis, where it will cluster your variables. Just now I say BI1 up BI2, BI3 up to BI6, and then leadership like LS1, LS2, LS3 up to LS5. All that you put under factor analysis, it will start clustering. It will start clustering for you. It will generate a diagram clustering cluster diagram. In the cluster diagram, you can see clearly what one first cluster, second cluster of what you call items. Item cluster. All the items will be clustered. In this cluster, you have 8 items. In this cluster, you have 10 items. In this, then you can start rearranging your analysis will be based on clusters, new clusters that we have created. So we call it factor analysis. Usually when we talk about factor, we mean variable, but in factor analysis, when we talk about factor means item. Item. That means BI1, BI2, BI up to BI6, and then LS1, LS2, LS3 up to LS5 items. This we are doing actually item analysis. They call it factor, but when we talk, we say factors. Factors contributing towards satisfaction of internet banking users to claim value. Factors, we mean the independent variables. If you have 4 independent variables, you cannot mention all the 4 independent variables in your research title, research topic, right? Then your research topic will be very long.
Yeah.
So you just call those independent variables factors. Factors contributing towards internet banking users' satisfaction in claim value. Factors. Factors there mean independent variables. There can be 4, 5, 6 independent variables. For each independent variable, there are items, that is measures. So the factors here is not meaning 4 independent variables, no. The factor here means all the items. Let's say we have 100 items, is the 100 item analysis. Why they call it factor analysis? Because eventually you want to group these items under a few factors. That's the idea. Once you manage to cluster the 100 items into a few factors, then you get a smaller size. Initially you have seven independent variables. But after you do factor analysis, you are left with only 4 independent variables. Initially you have 7 independent variables. 7 independent variables contributing towards 1 dependent variable, which is internet banking user satisfaction claim value. One dependent variable is influenced by 7 independent variables. But after you do factor analysis, all the 100 items you do factor analysis on it, start clustering, grouping from the 7 independent variables. Finally, after factor analysis, it becomes only 4 groups of independent variables. 4 independent variables. From 7 independent variables, now reduced to 4 independent variables. More manageable. Well, that is the purpose of factor analysis. In any doctoral study, you have to do factor analysis. When you do your DBA dissertation, when you do your dissertation is 2 years, right? You have to do factor analysis. Okay, what we have talked so far is about correlation. That means relationship between constructs. Relationship between independent variable 1 and dependent variable. Relationship between independent variable 2 and dependent variable. Relationship between or correlation between independent variable 3 and dependent variable. We are talking about relationship between independent variable and dependent variable. We are talking about correlation. If the relationship p-value is less than 0.05, it is significant relationship. That means it supports the hypothesis. There is a significant relationship between these 2 variables. Now we turn to exploring differences between groups. the second type of hypothesis. So we have two types of hypotheses in quantitative research. The first type of hypothesis is all to do with correlation, relationship between variables. That's the first type of hypothesis. The second type of hypothesis is exploring differences between groups to find out whether there is a statistically significant difference among a number of groups. Balance page 1 to 4. So you conduct t-tests for two groups, example male and female. You want to compare the mean score of between male and female, the mean score. So t-test. PET sample t-test, but this is at different times, time 1 and time 2. Usually you want to see the changes in the score. PET sample t-test. If it is cross-sectional, you use t-test. If it is longitudinal study, that means at two different times, you use PET sample t-test. And the last one is independent sample t-test. When you have two different groups, mates, for example, male and female, you are interested in comparing their scores. You use independent sample t-test. The non-parametric, if it is not a bell shape, then you have to use Matt-Whitney test or Wilcoxon sign test. So ANOVA is a one-way analysis of variance. It is a t-test when there are two or more groups to compare their mean scores on a continuous variable. It is called one-way ANOVA because we are looking at the impact of only one independent variable on the dependent variable. We call it one-way ANOVA, analysis of variance ANOVA. And one-way ANOVA, if you have only one independent variable and one dependent variable, you have different groups. You have male group and female group. You want to compare between these two groups, you use one-way ANOVA because you only have one independent variable and one dependent variable. That means you have two variables, only one independent, one dependent. You use one-way ANOVA. The non-parametric test for one-way ANOVA is Kruskal-Wallis test and Friedman test. When there is no bell shape, when you use selective sampling, you use Kruskal-Wallis and Friedman test. The two-way analysis of variance is to test the impact of two independent variables on one dependent variable. You have two independent variables and one dependent variable. So it is called two-way ANOVA. It's not one-way ANOVA. One-way analysis of variance. Now it is two-way analysis of variance, two-way ANOVA. But you have two independent variables. And then there is one called MANOVA. Multivariate analysis of variance is used to compare group on a number of different but related dependent variables, and we comparing the effect of different treatment on a variety of outcomes. If you have more than one dependent variable, then multivariate is called multivariate analysis of variance. But your dependent variable must be more than one. You have more than one dependent variable, you use MANOVA. Multivariate analysis of variance. So basically those are the basic SPSS tests that you will do later. But this is already a bit advanced. MANOVA is already advanced. So that finished our part 2 of this. So now you find how useful that really valid is. You can't memorize everything in your head. Okay.
That should be always visit.
Any question?
Research there.
Any question? Just ask any question before we do a little exercise.
This will be covered under RM1 or RM2?
What's the difference between smart PLS and SPSS?
Okay. Smart PLS is a very user-friendly statistical software. Very user-friendly.
Really?
You don't need any knowledge of statistics also, you can use PLS. What you do is you put all the data you put all the data in, and then you just use your mouse and just click, drag the arrows, click. Everything is in the diagram form there. Your independent variable 1, 2, 3, 4. Your dependent variable 1. And then your moderating variable, your predicting variable. And then there are arrows pointing from variable to variable. Arrows pointing. You just move the arrows. Click. Any direction you want to move the arrow. Testing, you are testing. Every time you move the arrow, the result come out. Every time you move the arrow, another result come out. You move this arrow, pointing another result come out. Very easy. Everything automated. But the danger is, even if it is not a normal distribution also, it will give you result, which if you actually cannot use. So you have to prove normal distribution first. You have to conduct normality. You have to do data cleaning. You have to do normality test. All that. You have to show that you did not violate your normality assumption first. If you before doing normality test, you straight after data cleaning, you straight away use smart PLS without knowing whether you violated or not violated normality assumption. You are using the wrong approach, because smart PLS will give you result in any circumstances. If the distribution is not Bell-shaped, not normal, smart PLS will convert it, will change all your data and make it into normal. They call it bootstrapping.
Then why they have such thing then?
Huh?
Why they have such thing?
You will manipulate your data, make it normal.
Why then they have such a software?
Smart PLS is normal then.
That's why you still have to conduct normality tests using SPSS. You have to do data cleaning. After data cleaning, do normality test. Yeah. Do Cronbach alpha test. Do normality test. Do all the data cleaning, normality test, or the what we call Cronbach alpha, which is reliability test, durability test, all the validity test, reliability test. Everything you have to do the basic test first. Once everything is okay, then you have to study relationships. Then you import everything, the final data. You import everything into smart PLS. Then you can start dragging the arrow. Okay, IV1 to dependent variable. Now I drag IV1. I drag this way to IV2, or I drag it to the mediating variable. I drag the arrow here. Every time you drag, the result comes out. Then it's easy for you to study relationship. But that is after your data is perfect. Cleaned up, everything perfect, normality assumption not violated, everything okay. Cronbach alpha okay. I think reliability, validity, all okay. Then only, finally, you use smart PLS to study relationships, correlations. It's very, very fast. Just dragging arrows. This arrow now point like that. Now you take the pointer, point it to another direction. Different data will come. Because it's in a diagram form, so it's very easy. Okay, so Okay, can take a short break. 10 minutes or what? People will give you a.
So 30 we will start.
Yeah, 30 will start the exercise.
Do we have another class for to run this?
For
Only one class.
okay.
Minimum.
So this is the basic SPSS. If you want another training, it will be more advanced SPSS. Testing valorization, testing. This is just a pilot study. What we end up today, after we do a small exercise, our small exercise on a pilot study or a sample of 50. It's a pilot study. I'll explain to you why we need a pilot study. Before actual study, you need to do a small pilot study of a sample of 50. This is what we're going to do in our exercise.